Welcome to In 5 Minutes. In this video clip, we will discuss one very important process which is called sampling. Sampling is used in converting an analog signal into a digital signal. The process of conversion of analog signal to digital signal involves two very important steps. Step number one is the sampling of the analog signal. After the process of sampling, we go for the next step, which is step number two, which is called quantization. So sampling plus quantization basically helps you to convert analog signal into digital signal. We will discuss this whole process of conversion of analog signal to digital signal in detail in the form of a system called PCM, pulse code modulation. Right now, we will discuss sampling process independently. So all we'll have to understand here is how the sampling process is carried out and what kind of output we get in sampling process. And the main aim will be to understand if there is any important criteria that is to be satisfied whenever we perform the process of sampling. So in very simple words, all we do in sampling process is we take an analog signal, which we also call continuous time signal, and we discretize the time variable of that signal. Now let me quickly recall the definition of a signal as we use it in the subject of signals and systems. A signal is nothing but a function of an independent variable. So there are basically two variables involved. The actual variable, the function itself, is the dependent variable. It depends on another variable which is called independent variable. In most of the cases, we consider the independent variable to be time variable. For example, I've taken such signal, the signal number 1 on the left hand side. I'm calling it x of t. X of t is nothing but some signal, some information signal, which is defined as a function of time t. So you can see here letter X simply represents the name of the signal. I can call it a dependent variable, and T, which is time, becomes the independent variable. You can see it's a continuous time signal because the value of signal X or function X is defined for all the values of time T. Obviously, we are just showing a small part of the signal between two time instants. So if I only consider the range of time which we have taken here, in this range I can say x of t is very much a continuous signal in nature. Now my aim is to discretize this signal. Now what do we mean by a discrete signal or discretizing the continuous variable? The signal x of t, which is defined for all the values of time t in the considered range here, we want signal x of t to retain only discrete number of values. We want x of t to retain only some finite number of values, and those values should be defined for discrete or some specific time instance. So let's say, for example, this point starts from time instant t0. At t0, x of t will have some value. I will read that. After that, I will go to the next time instant. Let me call it t1. At t1, x of t will have some value. I'll read that value in the output signal. After t1, I'll go to the next time instant t2. At t2, x of t will have some signal value. I will read that value in the output signal. Likewise, I'll keep on doing this. I may come to t equal to 0 point. I'll read the value of x of t again in the output signal. Then I go to the right hand side. Let's say this time instant is some time instant t10 maybe, let's say. At t10, I'll read the value of x of t. I'll go to the next time instant t11. I read the value of x of t again, and I keep on doing this. So you can see x of t, which was defined for all the values of time t, as a process of sampling, it will now be defined for only the time instants t0, t1, t2, then 0, then t10, t11, etc. So I can now have the same signal x of t, which will not have the values defined for all the values of time t. In simple words, this time variable t will become discrete in nature. So the process of sampling, in simple words, is to convert the continuous time signal to the discrete time signal. Please remember that discrete time signal is not digital signal yet. we have to discretize the amplitude axis also, like we discretize the time axis. So after the process of sampling, we have to perform the next process, which is the quantization, in which we basically discretize the amplitude axis, and that will basically give us the pure digital signal.